Welcome to Comprehensive Code YouTube channel. Today we'll be solving Leetcode 2597, the number of beautiful subsets. Let's read the question first and understand it. You are given an array norms of positive integers and a positive integer k. A subset of norms is beautiful if it does not contain two integers with an absolute difference equal to k. Return the number of non-empty beautiful subsets of the array norms. A subset of norms is an array that can be obtained by deleting some, possibly non-elements from norms. Two subsets are different if and only if the chosen indices to delete are different. Let's take this as an example, okay? The first thing, what are the subsets of this number? The subsets of this number is this 2 and then 4 and 6 and 2 4 and 2 6 and 4 6 and 2 4 6, right? Now let's see if which of these are the beautiful subsets. We are said like the beautiful subset is the subset where the difference of the absolute difference of the two numbers in the given subset is not equal to 2. Okay, let's see what is the absolute difference here. This counts as a subset with beautiful subset, but it should be non-empty, so we should not include this empty. Okay, first thing to notice. Okay, what about this one? This does not have absolute difference of 2, so we can include that one. We can include that one also. We can include that one, right? What about this 2 minus 4 or 4 minus 2? It is equal to 2. Okay, that's why we cannot include this subset. What about this one 2 6? 2 minus 6 is 4, so it is not equal to 2. That's why we can include 2 6. Okay, what about 4 6? 4 6 cannot be included because the absolute difference is 2. What about 2 4 6? It cannot be included because 2 minus 4 is 2, or 4 minus 6 is 2. Okay, that's why we cannot include that. That's why the number of beautiful subsets is 1 2 3 4. Okay, that's why 4 is the answer. I hope the question is clear now. Let's talk how we can solve this. Okay, the solution is pretty much simple. Okay, let's talk how we can do that. I think you are familiar with the subsets, how we can solve the subset problem. If you have an idea on that, it's pretty simple. Either you can take it at its index, so for example 2, or let's do this. So start with empty, and on each index either you can take it or not take it. Okay, basically if you don't take it, you'll be left with empty, and if you take 2, you will have 2. Okay, now can we include 2? Yes, we can. And how we can check that is if we can maintain a frequency or map where we will have we'll store like this particular number is already visited, or even better we can check in a number if we have 2 minus k or num minus k or 2 plus k. If this has not been visited or if this is not in the frequency map, we can include that. Otherwise, we cannot include this number, right? I think that makes sense. So if you now, if you if you go beyond this tree, you don't include 2 and you include, okay, you don't include 4 and you include 4. Can you include 4? You'll check like if 4 can be included. 2 minus 4 is 2. That's why we cannot include this. We cannot go in this path, okay? We can stop it here. And not including case is just 2, okay? It will be just 2. Okay? And similarly we go other route in the same way. I hope it makes sense and it will be very clear when we write the code. If you are familiar with the subset problem, it is pretty easy. With that, let's start writing the code. Okay, so like I mentioned, like we'll define count so that like we can return this count at the end. Okay, this count is the number of beautiful subsets that we'll be seeing. Okay, and then let's define explore, and this is a backtracking depth first search. Okay, and we pass index and we call this explore. Okay, we call explore and we'll start from the starting position. Okay, and as we said, like we also maintain a dictionary of visited. Okay, default dict of integer, so that we can see if the number is already visited using that, or num plus k. Okay, if that is already visited. Okay, so now let's see if also let's do length of the nums is len nums. Okay, cool. And if len nums is equal to index, if that is the case, what we can do, we can just increase the counter, right, and return. Okay, otherwise, like I mentioned before, if we have to mark that as non-local count so that we can access this count variable inside this explore method. As we said, if the nums at index, let's say this as num is nums at that index. Okay, if nums at that index, that means num minus k not in visited. Okay, or num plus k not in visited, we can take this, right? That means we just mark this as visited, num plus equal to 1, and we can explore to another index. Okay, and the backtracking, you remember, like we just revert what we have done before when we go to the previous state, okay, so that this state is maintained. Okay, now if visited of norm is equal to 0, we just delete that, delete visited norm, okay, so that like this key is not seen here again, like that's why we delete it, okay. And this is the take case. We can take this, and there is another case where we don't take this number, right? So just to explore index plus 1 in that case, right? Okay, so let's see what we have done so far. Okay, what we have done so far is, okay, so we defined a visited set so that we can check if this num minus k, which should be and, because both should not be present, okay, if num minus k and num plus k is not in visited, okay, and then we mark that number as visited, and we explore another number, and then if the visited is 0, then we delete that, and this is the take case, and this is not take case, okay, and we just explore from the beginning of the array, and if we reach the end, we just increment the counter and return it. And another thing, important thing to note is, remember, like we don't have to include this empty subset. That's why we just do -1 at the last, okay, so that we don't include this in the count, in this empty subset in the count. I think that's pretty much it. With that, let's run this code, and you can see it passes these two test cases, and let's submit it. Oops. As you can see, this is pretty much efficient. Let's run this again. Yeah, if you run sometime, it will be I believe like it will be far beyond this percentage. Yeah, this is pretty much efficient, and if you find this helpful, just subscribe me in my channel. I'll bring more of these solutions in the future, and please hit like and subscribe button in my YouTube channel. That will help me a lot for growing. I'm in growing phase. Thank you for watching this, and I hope we'll meet soon in the future.